How are you everybody who is watching this video? My name is Olenjolai TAYAI from beautiful, fantastic country, United Republic of Tanzania, or in short we call it Tanzania, in eastern of African continent. I would like to welcome you onto our online school, which online institute is called the Online Diploma Polytechnic Institute of Tanzania, in square bracket Olenjolai. We are very happy to welcome you into this fantastic online platform where we teach our diploma students all the concepts which are essential for them to become competent technicians, to solve real-world problems. And we'll be teaching them to think differently and even to take the classroom instructions to apply to solve problems, real-life problems in the year community. So in these online platforms or diploma platforms, we are really preparing technicians, as I say, because our intentions, our vision, we want to see a community of diploma students who are still doing diploma program, and even after their graduations, they take the classroom instructions and then solve real life problems. However, that will be focused on the syllabus of Tanzania, or syllabus of Tanzania, which has been accredited or prepared and then has been accredited by the NACTE, National Technical Council. Okay, we call it the national. It is called NACTE. Okay, NACTE, National Technical Education. So, or Technical Council, we call it NACTE, because NACTE, it is National, right, Council for Technical Education. National Council for Technical Education. So this is authority which has mandate according to the laws of the United Republic of Tanzania to accredit any syllabus of diploma level. Okay, so we have basically a departments of engineering and scientific mathematics. In this, we'll be teaching mathematics in this program for the diploma level to help students who are doing engineering courses or engineering courses or scientific courses. So the course of the module of the day is called the Conics. In some of the institutions, they call it the coordinate and differential question. And this course, it is taught to engineer and scientific technicians. It means that engineers, technicians, scientific technicians, and the engineering technicians at NTA level 6, National Technical Award level 6, or third year of ordinary diploma. This is not a channel for the advanced diploma. This is the channel for ordinary diploma. That's why it's been written that Online Diploma Polytechnic Institute of Tanzania. And then so we'd like to welcome you onto our YouTube channels that called Online Diploma Poly Institute of Tanzania, in square bracket is called the OLENJOLAIM. We have that, we have a session or a lecture that has been called the 00, the general introductions of engineering and engineering and scientific mathematics in this YouTube channel. You have to make sure that you go through that channel, because we provided the general introductions of the 6 modules which a student has to learn during the 3 years academic. So it means that in each semester he or she is going to learn at least one module or one course of scientific or scientific and mathematics engineering. So get prepared to enjoy the beauty of mathematics. Get prepared to answer some of the homeworks that I'll be leaving to you. Get prepared to be challenged. Get prepared to ask questions through the comment sections, and get prepared also to enjoy the beauty of mathematics. Even if you've been lost for some times, I believe that God will help me to assist you to restore your love of mathematics since you have been in nursery school or maybe in primary school. I know that your love of mathematics, but possibly because of the way you've been trained, possibly that you've lost your love and even you've lost your track. But mathematics is beautiful, and I want to tell you that it's the queen of engineering. So we need mathematics on solving real-life problems of engineering. So we'll be doing a lot of things in this program. We need students who are serious. We are very serious on this program, and also we need students who are serious and who have already dedicated themselves to learn and be ready to adapt to something new and practice different questions and even different homeworks which will be left. But again, in case you feel from your heart that you want to offer your Thanksgiving offering, you can offer through this telephone number 0759745331, and then your offering will be received and used effectively to pay the running cost for this program. So many videos of scientific and engineering mathematics will be in the air for the present and future generations. Don't forget to share this content with your classmates so that you'll enjoy it together and at any time and also anywhere. So also you're allowed to watch this video several times as well as you can until that the concept which will be taught has been well understood and you can keep it in your mind. So these technical awards, as I say, that is or the diploma or not diploma, it has been supervised by the National Council for Technical Education, in short we call Dit Nacte. So before we go on to contents of the subject or module that's called the Conics, remember that I would like just to clarify this point for you. In many institutions or colleges, some of the colleges they use the word conics, but some of the colleges they use the word coordinate geometry. So conics means it is coordinate geometry, and when I'll be explaining the parts of conics, then you'll understand why we call conics the coordinate geometry. Right? So conics or coordinate geometry. So I want to mention some institution in Tanzania or colleges, right? This material are relevant to any ordinary diploma students worldwide. Colleges, right? So colleges in Tanzania that offer ordinary diploma, and the students has to cover or has to learn this module. The first one is called the Dar es Salaam Institute. Okay, Dar es Salaam. So we mentioned some. There are Dar es Salaam Institute of Technology. There they offer more than 13 courses in scientific, in science and engineering. Okay, technology, which in abbreviation called DIT. So this institution, it offers more than 13 ordinary diploma program. So in each level, in many courses of scientific and engineering, they also do this course or module, they call it a module of conics and differential questions. So if you are studying at the Dar es Salaam Institute of Technology, this material are for you. Okay? Then the second institution which I saw it or I want to mention is called the Arusha Technical College. So Arusha Technical College, right? Arusha Technical College, in abbreviations is called the ATC. So it's northern in Tanzania. This is in eastern of Tanzania, in the business headquarters of Tanzania, that's called Dar es Salaam. And this one, it is Arusha Technical College. It is northern of Tanzania, where you find a number of of my relatives who are in tribe of Maasai, right? I'm a Maasai, so there you'll find a number of my relatives of the same tribe. So you'll enjoy this because we are kind of unique in terms of culture. So in Arusha Technical, there are many courses, more than 8 courses, ordinary diploma courses, which actually that they have to study this module at NTA level 60, first semester. Even the Islam Ministry of Technology will do this module during the first semester. In Arusha Technical, you'll do during the first semester. However, at Arusha Technical, this module is called, so the name is not the issue. The issue is the content. It's called coordinate geometry, okay, coordinate geometry and differential equation. So there are many institutions call this module like this one, differential equation. Differential equation. Then the third institution is Mbeya University. Okay, Mbeya University of Science and Technology. Science and Technology. I might be calling one of the names that I've mentioned there, and technology, right? And technology. So this, in short, we call it MUST, right? In English, you call it MUST, but in Swahili, you call it MUST, right? And then the first reference institution is called the Karume. This is found in Zanzibar, Iceland. Karume Institute of Science, Institute of Science and the Technology. Institute of Science and Technology. So this in short is called the KIST, right? So also they, in NTA level 4, they have more than 5 ordinary diploma program in engineering and science, and also the students, they have to pursue this module or this course in NTA level 60, first semester, meaning third year of first semester. The last example of institution that students used to study this module in Tanzania is called the mineral resources Institute. So this is found in Dodoma. So in short, it's called the MRI. This is found in Dodoma, right? So Mineral Resources Institute. So etc., etc., etc. So there are many institutions and many colleges and many universities that offer ordinary diploma in science courses and engineering, and they have been accredited by Dit Nacte. They have to those institutions or colleges or universities, they have to teach their students in the third year the module or course called the coordinate geometry and differential equations, or conics and differential equations. So that is a brief introduction that I wanted to share or to present to you. Again, now let us go to the contents. What are the contents of the module, right? So when we say contents, we say that, let's say, let us start with topics of this found in this course or in this module. So let us start with topics or chapters of conics, which is coordinate geometry, conics, and differential equation. So this module, you can divide it into, it's frequently divided into 2 parts. The first part is conics, and that's the one that contributing question for the test 1. And the second part is differential equation. It's the one that contributing questions for the test 2. But in case of the final exam or university exam, you will find questions from both parts. conics section and also the differential equation. So basically that's what we say, that we have part A, which we call the conics, and then so we have second part, and as I say that this is the coverage in most of the institutions or college or universities for the test one, worldwide and especially Tanzania. And then so you have the second part, which is called the differential, so differential equation, right? So differential equation. So differential equation, this is DE. So this is the coverage for test 2. But in case of university exam, it covers both. Some of the institutions call it final exam, some of the institutions they call it UE, university exam. So then I want to present to you contents, because we're gonna start with contents of 40 of conics. We're gonna start with conics first, and later on I will teach about differential equations. And as I told you, this is the problems. I don't know everything about conics and differential equations. I want to let you know in advance. I know small portions of it, but I'm ready to teach others what I know in conics section and differential equations. I'm always learning new concepts in conics and differential equations, but I'm ready to teach what I know in order to assist you to solve real life problems and even to tackle or to pass your exams, your test 1, test 2, and final exams without any supplemental. So contents of conics sections, okay? So this one, it is, so we call it contents or topics, let's say. Okay, we still that you are discussing topics. So contents of, yes, I think that the best way we have written their topics or chapters of 40 of conics and differential equation. So for part A, let's say that if you start with conics, I will be teaching you 4 topics. The first one, we call it cycle. Okay, cycle, say cycle. So cycle, in case for your colleagues who have gone for advanced certificate or advanced level, who are doing advanced mathematics, they used to learn cycle in the first topic of Form 5, that's called coordinate geometry 1. And I have also official YouTube channel that I'm teaching A-level mathematics, A-level advanced mathematics, basic applied mathematics, Form 5 and 6, and then advanced physics from 5 and 6, and advanced chemistry from 5 and from 6, so that you can let them know it's called Tanzania Online A-Level Secondary School, right? The second topic that I will teach you about parabola. And parabola, this is the first chapter, is found in the topic called coordinate geometry 2, for those who have gone for advanced level. Is the first chapter in Form 16. And they use, for the A level, they used to start detailed parabola, detailed ellipse, and detailed hyperbola. But for other diploma, we are just introducing them. And where do we use the concepts of conics? Have you ever seen parabolic dishes? Yes. So you have seen them to receive them, the television signal, for example, to receive the radio signal, or the telephone signal, etc., etc., etc. So those are, for example, parabolic dishes are the results of applications of conic section. Okay, because of the shape. Then the set topic that I will teach you about ellipse. Say ellipse. Okay, and then the first topic I'll teach you in conics is called the last one is called the hyperbola. Right? So that's what we will cover together in this. Also, the syllabus used to, or the course outlines used to ask me to teach about rectangular hyperbola, but we don't study it in detail like when we are teaching advanced mathematics, because for them, their syllabus, they used to learn a lot, detail the hyperbola, detail the ellipse, detail parabola. But for the cycle, yes, actually we have to teach you at least to the same level of what you cover in cycles. So remember that for the Form 16, these 3 chapters are the one that making coordinate geometry 2. While this is for the Form 5, it's called the coordinate geometry 1. the first chapter, this is the fifth chapter for the Form 6. So while you are learning about Conics sections, even also your classmates are still learning it in the year advanced education. So then I want to take you now onto the contents. Let us start with the contents of 40 contents of the topic called the cycle. Right? Contents of the topic called the cycle. Right? What am I going to teach you in cycle? Good question. The first thing which I will teach you about general introduction. Introduction of cycle. Right? Introduction of cycle. Then the second thing, after introducing you about introduction of cycle, I will teach you about the derivation. Okay? Simple derivation, not a complex derivation. Derivation of equation of the cycle. EQN, it is equation of the cycle. Right? Equation of the cycle in or on XY plane. So we have a cycle centered at origin and the cycle centered at any point in the on the XY plane. The third concept again I'll teach you about equation. So EQN means equation of the cycle. So equation of the cycle passing through 3 points. 3 points. And then the first chapter or the first concept that I will teach you, I will teach about conditions. Condition for a tangent line or for a straight line, for a line to be a tangent. And this is a prerequisite of all the next 3 topics. That the condition for a line to be a tangent, a straight line to be a tangent to the parabola. Also, there's a concept that we're going to teach you, that condition for a straight line to be a tangent to the ellipse. And also, we'll teach you about the condition necessary for a straight line to be tangent to the hyperbola. So you see that we'll be singing the sum of the tangent, a line to be a tangent to what? Because this is still general. Tangent to the cycle. The cycle. Okay, so then we have 1.5. So 1.5, we say that we have to teach you also equation of tangent and the normal. So tangent and normal line to the cycle. How we can find its equation or equation of the tangent and normal line to the cycle. Right? So we're going to teach you. Then 1.6 will teach you about internal intersections of the cycles. What is necessary condition for the cycles internal intersection? What is necessary condition for the cycles to intersect internal intersection of cycles. Internal intersections of cycles. To have 1.7, which you're going to teach about external intersection. External intersection of cycles. Right? Then the next concept that we're going to cover will teach you about orthogonal intersection. Orthogonal intersection of cycles. You have to make sure that you have your reference books close to you, because we're going to use them and solve some problems found in your reference books. So 1.9 then will teach you also about the concept, we call it problem solving. However, that the issue of problem solving will be going on throughout the entire topic. So when I will teach you about parabola, I will list also its contents, ellipse and hyperbola, and even differential equation, so that even to reduce the weight of contents for you to handle them in your mind. So these are the subtopics or the concepts that we're going to cover throughout these concepts of the cycle. Stay connected. We're going to upload many videos in this channel, YouTube channel. So make sure to subscribe so that you'll be the first one to be notified by the YouTube once we add or we upload a new video. Okay, so today we'd like to start with introductions, as the subtitle is written there, introductions of cycle, right? That's what we have to start with. Introduction of cycle. When you introduce the concepts of cycle, you should not confuse what you have learned during your Form 3 educations, because the 6th chapter is called the cycle. So there you learn the cycle, but you learn the cycle as a cycle, but not as a part of the coordinate geometry. Here we are teaching you the cycle when it is a part of 40, it's a part of the XY plane, right? Part of XY plane. Our fundamental question, once you want to understand first of all the term, before even the thing that, or maybe the details of that concept. So I have always to ask myself this question, right? What is a cycle? But before we define a cycle, it's better if we define this question. How do we get a cycle from a conic section? We'll come later onto these questions of what the means of the cycle. So this is the question. How do we get? So you can pause the video and then think yourself. How do we get a cycle from the conic section? That's the question mark. How can I get a cycle from the conic section? Because all these 4 conic sections, cycle, parabola, ellipse, and hyperbola, are the resultant of cutting a cone in a particular dimension or in a particular angle. That's the question, right? So this is the answer. Let me answer. If that you have tried to ask yourself, you have your answer, so you can check whether it's right or not. A cycle is the conic section. First of all, a cycle is the conic section. Cycle is the conic section, right? Which is obtained when a plane cut a section of cone section of a cone in its surface element. in its surface element. Surface element in direction to the axis of that cone. In the direction of axis of that cone. Okay, so that's how we get a cycle. First of all, a cycle is the conic section, which is obtained when a plane cut a section of a cone in its surface element in the directions of axis of 40 of that cone. So we say that suppose we have a cone here, suppose that that's a cone. So how do we get a cycle from that cone? So to get a cycle from that cone, we just cut this cone like this. So this is cone. Okay, and that is what is cutting the conic to give out the cycle. So that cone is the one that's giving us the structure for the other, for the parabola, for the parabola. Okay, so now we know how we get a cycle. The next fundamental question now, which is question 2, what is a cycle? Okay, we know how to get it. What is a cycle? Think. Take a moment, let me challenge you. Take a moment, pause the video, think. What is a cycle? And then try to write your response, and then so we come back and make corrections of what we are learning about, right? So remember that we will never teach you how to cram. We always try our level best to let you understand what you have been teaching. Okay? So after cutting now, we can have a cycle like this. This is radius. And then this here is something called the diameter. So that is. So what is a cycle? Now ask your neighbor. After asking yourself, then ask your neighbor. And have a discussion before you read mine. Cycle, don't define like how we defined in your form 3. Is a locus. Say locus. Is the locus of the point. So this is the locus of the point, which moves so that it is always, so this is the locus of the point, which moves so that it is always equidistant. It is always equidistant from the fixed point. From the fixed point. So you say that a cycle is a locus of a point which moves so that it is always equidistant. It's always equidistant from the fixed point. That's one of the definitions. The first, the second one, let me give you, and then I'll explain it briefly, and then we'll continue. Okay? So another definition, you say that a cycle is a locus. That's why that I told you can have it in the definition also. The issue is you have just to include the values. So it's the locus of the point. The locus of the point which moves so that, similar to the first definition, so that the distance from any point in the cycle to the fixed point is constant. So that the distance from any point say that it moves so that the distance from any point from any point of the cycle so which moves so that the distance from any point of the cycle to the fixed point, this is equal to radius. The fixed point equal to radius is always constant. So this is always constant. So a cycle is a locus of the point which moves so that it always equidistant from the fixed point. What is of the fixed point? Radius of the cycle. So that's the first definition. Secondly, similarly, but it contains some more information, is a locus of the point which moves so that the distance from any point of the cycle to the fixed point is always constant. So you may use either of the definition to define the term knowledge called the cycle. Right? So that is the definition of the cycle. So you say that, for example, okay? Suppose that is the center. So if I move from this point to this point, then I've moved it from point A to point B. Okay? And then, for example, that from here to here, C to D. So C to D. So this is distance, and this is distance too. Okay? So you say that the locus of the point which moves so that distance from any point of the cycle, even from here to here, we say that to the fixed point or radius is always what constant. So the distance from here, from distance to here, right? It's like that. So these distances are equal according to the definition. B1 is equal to B2 is equal to B3 is equal to B4, etc., etc., etc. Right? So that's why that we say we have to deal with this situation. Don't forget that also in this channel we teach O-level student the science courses. So you have to make sure that you go through and enjoy the beauty of science and mathematics from the secondary level. Okay. Do you have any question about cycle at that point? We have again another terminology which is called the radius. Radius, and then we have another terminology that we call okay. So we begin with the concepts of radius. So radius is the fixed point. Okay, so this is a fixed point, called O, or we call it the fixed point or center of the cycle. Okay. Again, we have a terminology that we call the radius, it's the distance from the center to any point. We have a terminology that's called the diameter, right? That's the distance from the one point of the circumference to another point by toward the center. So those are the few terms. So you say that as the center is a fixed point in the cycle, and then diameter, we say that what is diameter is the distance between 2 points of the circumference of the cycle passing at the center of the cycle. So you say diameter is the distance between 2 points of the circumference of the cycle passing at the center of the cycle. While radius, the fixed distance from the center of the cycle to any points of the circumference of the cycle. Right? So that's the point which is very important. Any point of the circumference of the cycle. So you know the radius, you know the diameter, you know the center. So no need for us to waste the time there. So you say that another piece of information, you say that a cycle can be either at the center or origin or translated. The cycle can be either at the center or origin or translated on the XY plane. On the XY plane. So you say that a cycle can be either at the center or origin or translated on the XY plane. So now let us start with the second concept about derivation of the equation of the cycle. So equation of the cycle. Say equation of the cycle. Equation of the cycle centered at origin. Was depends centered where? Okay, so equation of the cycle centered at what? At origin. So we can have a question, for example, this is an example 1. Okay, example 1. So example 1 asks you that with 8 of diagram, so you say that with 8 of diagram, with the aid of diagram, derive equation of the cycle centered at origin. Centered at what? At origin. So it's the aid of diagram, derive the equation of the cycle centered at the origin. So we have derived the equation of the cycle centered at origin, and then we'll end this lecture 1. So you're gonna follow a few steps. So sketch the XY plane. Then you have to show it's a cycle. So I'm sketching, I'm not drawing. So this is y-axis, this is x-axis. Okay? So this is the center. Coordinates are always 0, 0. So suppose that this is the cycle, and here we have a certain point. This is point P, an arbitrary point, x, y. And here we have 0, 0. And we need the slope of this point. So this is the right angle triangle. So you have changing y, and there you have changing x. Right? So this is the cycle. Postulate. I sketched it wrongly. Okay, so that's the cycle. This is point P, this is point O, and this is point B. So we want to derive equation of the cycle. So let us end our lecture with that general equation of the cycle, so you may enjoy going through it several times. Okay? So you say that for this case, from Pythagoras theorem, Pythagoras theorem of this right angle triangle. So right angle triangle to OBP. So OBP, that's a right angle triangle. So we say that for this case, the hypotenuse, which is OP square, this will be equal to adjacent, which is OB square, plus what? Opposite side, which is PB square. That's according to what? Pythagoras theorem that you learned during your studies of the O-level before you reach the Form 4. Then what is OP? Well, OP is X. It is X, so OP. It is X minus 0. This is equal to what? X minus 0 plus what? Y minus 0 square. This is, let me check, Pythagoras theorem that we have to recall here. OP. Okay, so this is the radius of the circle. So the hypotenuse, the value of hypotenuse is r squared. What is OB? OB, that is horizontal. Right? So OB it is x minus 0 square. OB is the distance from here to here. Right? So here you have x comma 0 because y is 0 at this point. So x minus the coordinates of x here, which is 0. And then plus. Then we go for the coordinates of y. Right? Okay? So we say that for y, we say that because here it is, this point is x comma 0. So y minus 0 is y. So even here y minus 0 square. So x minus 0, it's x, and y minus 0, it's y. So that's why I say that this is r square, x square, plus y square. You use the equation of the cycle in the many contexts, but you didn't understand how to derive it. So you say that now the general equation of the cycle centered at origin is given as r square is equal to x square plus y square. So this is the general equation of the cycle centered at origin, like what I've shown here. Very interesting question. We'll need it in solving different problems of mathematics, including those that will be asking us in the cycle. So let's say that this is the end of session 1 or lecture 1 of introductions of the cycle. Join me in the second session when I'll be teaching you how to derive the general equations of the cycle when the cycle has been translated from origin to any other point, whether that in positive directions or negative direction of the xy plane. So this is the end of the session 1. May God bless you. May God bless. Also, I thank God because He's the one who has given me the strength to look for this material and even to sit down and prepare it. I have to give Him all the glory. And also thank you also for taking your time to listen and making a follow of what you've been doing. May God bless you also abundant. I'd like to invite you in lecture 2 or session 2 of what? Of Conics, especially the part of the cycle. You'll enjoy it. I have a number of questions from Pure Mathematics 1, and even some of them are from Pure Mathematics 2, and even some of them come from some other reference books, right? So stay connected, stay tuned. Make sure to subscribe to get notification once we add a new video, and then stay connected. Join me in the next lecture. May God bless you so much, so that you'll be prospering on your academic.